A pleasant afternoon to each and everyone, especially to our very dynamic and brilliant professor, Professor Ariel Ilari. By the way, we are the Group 1 and we would like to thank everyone for being here today as we all gather to learn, enjoy, and cherish our best effort for today's presentation to share all the important lessons while having fun at the same time. Again, I welcome you all to SED 127, Fluid Mechanics for Teacher. For today's insightful discussion, our group will discuss Module 1, which aims to discuss the respective topic. Module 1 outline. First is all about the concept of fluids. Second will be density, specific gravity, and specific volume. Third is viscosity. Fourth talks about surface tension. Fifth is compressibility. And last but not the least, characteristic of a perfect gas. But before we proceed to our proper discussion, let us first introduce ourselves. Well, I am Maria Casario Michelle K. Mendez.
I am Tony Rose Sanflor Rinuel Maxine Alcover Pelota.
Hi, I am Jaga M. Lisondra.
I am Glyza Rose Sisi.
Hi, I'm Riz Lafayette Q. Pagayan.
I am Napsika Kate Galior.
Hi guys, I am Christina Jill C. Dulugmandin.
I am Jaiza Amisola.
I am Jeremy Alcantara.
I am Ronald Angelo C. Olar.
I am Rexy J.B. Halina.
I am Jebo Marily Balansa.
The first topic we will discuss in Module 1 is all about the concept of fluid, so I hope you will all enjoy our presentation. Objective: at the end of the discussion, the student will be able to understand fluid, can define fluid mechanics, and understand further about fluid mechanics. So without further ado, let's delve to the world of fluids. Understanding fluids. Any substance which can flow is known as fluids. For example, gases and liquids. We all know that water, milk, and honey can flow, so they are all considered as fluids. Now, here's one of the most important concepts which a lot of people do not try to learn. In the definition of fluid, it was stated that any substance which can flow. So, what do you mean by substance which can flow? Well, let's consider water as an object. We know that water molecules are continuously moving. Water molecules are constantly changing their relative positions. Thus, we can say that all the molecules of water are relative motion. And the definition substance which can flow means that all molecules should be in relative motion like the relative motion of water molecules. This is the most standard definition of fluids. Any substance in which molecules are in relative motion, are in relative flow, is known as fluids. Let me ask you a question. Can we call sugar and flour as liquids? Because if you tilt a spoon of sugar and a spoon of flour, they both flow downward direction. Can you guess the answer? Well, the answer is obviously no. The molecules or particles of sugar and flour do not change their respective position with the passage of time. Hence, they are not fluids, they are solids. They fall off from any object due to their respective weight. Now, let me also clear your concept of mechanics. Mechanics is a branch of science which we study about force and its effect. By effect, I mean magnitude of force, direction of force, and etc. For example, consider a stationary football. When you kick it, you exert force on it. So force produces acceleration. So just remember that in mechanics, we study about force and its effects. Now, what is fluid mechanics? The branch of science in which we study the behavior of fluids under the action of forces is known as the fluid of mechanics. Fluid mechanics is further divided into three parts: fluid statics, fluid kinematics, and fluid dynamics. Now, what is fluid statics? Well, the word statics means at rest, and we already know about fluids. I mean, it is either gas or liquid. Thus, we can say that fluid statics is the study of fluid at rest. Now, what is fluid kinematics? Study of fluid in motion, neglecting pressure forces, is known as the fluid kinematics. And we define fluid dynamics as the study of fluid in motions, considering pressure forces. Just remember that fluid mechanics is further divided into three sub-branches, like fluid statics, fluid kinematics, and fluid dynamics. At this moment, remember that fluids have different properties like density, specific weight, specific volume, specific gravity, viscosity, surface tension, etc. All of these properties of fluid will be discussed by my group members because this is just all about the introduction of fluid mechanics.
Safe and doing good today. Let us now proceed to the density, specific gravity, and specific volume. What is density? It is defined as how tightly or loosely packed a substance is, or to the number of things or people in a certain area. The density of a substance is the relationship between the mass of a substance and how much space it takes up, or the volume. The most often used symbol for density is the letter P, but we can also use the capital letter D to represent it. In calculating the density, we can use this formula. P is equal to m over v, where P is the density, m refers to the mass, and v pertains to the volume. The SI unit for density is kilogram per cubic meter, but the most widely used unit is grams per cubic centimeter, or the grams per milliliter. Let me give you some examples. You have a rock with a volume of 30 cubic centimeter and a mass of 60 grams. What is its density? So we are given the mass and a volume already. So the mass is 60 grams and its volume is 30 cubic centimeter. In order to solve it, we have to use the formula P is equal to m over v. So the next step is to replace m and v, or to substitute it. So we have to replace m with 60 grams and the volume, or v, into 30 cubic centimeter. So let us divide it. 60 divided by 30 is equal to 2. So the density of the rock is 2 grams per cubic centimeter. Easy, right? Here's another example. A solid ball has a mass of 50 grams and a volume of 20 cubic centimeters. What is its density? So the mass and the volume is already given, where the mass is 50 grams and the volume is 20 cubic centimeters. In order to calculate or solve the density, let us use the formula P is equal to m over v. The next step is to substitute or replace the m and the v with the given values. So we have now 50 grams and 20 cubic centimeters. Let us divide. 50 grams over 20 cubic centimeters is equal to 2.5. So the density of the solid ball is equal to 2.5 grams per cubic centimeters.